Start with the assignment number 6 of week 6. Question 1 asks us which type of indexing is preferred for the given schema, and we have to create an index on constant ID. So there are types of indexes such as dense index and sparse index. This dense index is created on each entry, mainly on primary key, and sparse index need not be created on each entry. Now as you can see, the constant ID is not sequential and not in a big amount, hence using sparse indexing is not preferred, but dense indexing is preferred since it can fill the memory and it is small as compared to size of memory. Let's move on to question number 2. Here we are asked a question on properties of B plus tree, and we are asked which of the following statement is or are not valid for the given tree. In a B plus tree, all the leaf nodes must have between 4 to 7 values. That is, they should have m by 2 to m minus 1 values. And all the non-leaf nodes can have children between 4 to 8. And all the nodes should have minimum m minus 1 upper m minus 2 upper limit minus 1 keys, m by 2 upper limit minus 1 keys, and for non-leaf nodes minimum m by 2 children must be present, and any node can have m minus 1 maximum amount of keys. So in a case the m is 1 2 3 4 5 6 7 8, m is 8, and we can have up to 7 keys. So, and in a B plus tree, no leaf nodes are empty, hence D is the incorrect statement. Now let's move on to next question. A 2 3 4 tree is nothing but a B plus tree with m value equal to 4. Now we are asked how many comparisons are required to find 10. It is just like binary search tree, hence smaller values on the left side and greater values on the right side. So when we check the smaller values, we will have to first check 61, then 53, and in this bucket we will first check 9, and then for 10 being greater we will check on its right, we will find 25, hence 4 comparisons are needed. For question number 4, we have to identify the hash function. The best case scenario in this example is going from option. You can easily see that id modulo 3 is incorrect since 23 modulo 3 will give you 2 and it is stored in bucket number 1, so this is incorrect, and you can similarly eliminate other options and C option is correct. Next question asks is again 2 3 4 tree can store a maximum number of 4095 number of keys. What will be the minimum height of the tree? Here maximum number of keys is given, that is m minus 1 is given, that is 4095, so m will be 4096. So the formula is actually log of this is m and minus 1, which is equal to base. Here again m is the base, the m here is the maximum keys in a node, and n is actually number of maximum keys. So that simplifies to log of n plus 1 upon log of m minus 1, and the answer calculates to be 5. So option number B. Here we are asked to insert 85 when the tree is right biased B plus tree, that is when overflow condition occurs and number of elements is even. Suppose 733 75 80 and 85. The node, the value, the key on the right side of the middle, that is this one, will be pushed upwards. You can see the changes here. First 85 is inserted, overflow occurs, then you push 80 upwards here, and again overflow occurs in the root node. The root node will be split and 80 is again pushed upwards. So this is the option. If it was a left biased tree, then the left node is pushed upwards, that is 75 would have been pushed upwards. Now in question number 7, extendable hashing is used, which is a popular technique in DBMS, that is type of open hashing. In this type of hashing, we have directories and which point to buckets. Directory has a global depth associated with it. Buckets have a local depth, and the local depth is always less than or equal to global depth for the bucket to not be totally filled. And the global depth is number of bits in the directory ID. We have to find the incorrect statement. Since inserting 18 won't need a new bucket, considering the hash function to be x mod x, you can easily calculate 18 mod 8, which will result into 2, and convert that into binary 0 1 0. That means 18 will be inserted here, no new bucket needs to be added, hence this is the incorrect statement. In question number 8, we have been asked a question upon number of blocks, number of records. We are given that 128 blocks are required to store a file, and out of that, a block can hold either 48 key pointers or it can hold 16 whole records. A simple formula is number of records equal to number of blocks times number of records in each block. Since we have to find out number of records, we will keep it as n, hence number of blocks needed will be equal to n divided by number of records in each block, that is given 16 records. So n by 16. Number of block needed to store the index file, we will get n by 48 in a similar manner. Total blocks required will be n by 16 plus n by 48, that is 4n by 48, that is n by 12, which is given as 128 blocks. So when you multiply 128 by 12, you will get 1536 records. Hence option B is correct. Question number 9 asks us about bitmap indexing, that is used in DBMS. Bitmap is very easy. If a certain value contains in the attribute column, you will map 1 as the bitmap, and if it doesn't, you will map it to 0. So we are asked to find bitmap indices of data structures and sessional. Since data structures is not present in tuple 1, you will mark it bitmap as 0, and since it is present in second and third, you will map it 1. Similarly, for sessional, you will map 1 where it is present. The 2 bitmaps are top to bottom, so the option D is correct. And for the last question, it's on bitmap index, and we have to do it on attribute type of following table, that is relation course. And the syntax is given over here: create bitmap index name on relation name and then attribute list. Hence option A is correct. Thank you for watching, and keep liking the videos. Subscribe the channel. Thank you.